simplified first because when you start working with polynomial functions, you get some imaginary solutions sometimes when you start solving them. And if you haven't reviewed that, then anyway, so that's why we do 4.5 first. So 4.1 is a lot of just kind of definitions and terminology. We're going to define polynomials, divide polynomials. We're going to apply the remainder theorem, the factor theorem, and determine the maximum number of zeros of a polynomial. All stuff you've done should be short and sweet. The definition of a polynomial. A polynomial is a function. So first of all polynomials are functions. So they're all functions, and basically you have x to some power. You can have coefficients on them, and then you have x to a lower power plus all the way down till x is no power, which would make it a constant. A, B, and C, and D, any of your coefficients are all real numbers, and your first coefficient right here cannot be 0. And you cannot have, your ends all have to be non-negative. So in other words, you can't have negative exponents. They also have to be non-negative integers. So your exponents, just kind of summarize here. So your exponents cannot be negative, cannot be fractional, decimals, you want those, can't be fractions, and no imaginaries in the whole thing. No imaginary, period. So that's kind of a, in, what? Oh. Oh yeah, there you go. So, oh, here's another word. Okay, I have a slide for it. The leading coefficient cannot be 0. All coefficients have to be real numbers. In other words, you can't have imaginary. And exponents must be whole numbers, can't be fractions or negative. Okay, I just said all that. So, let's decide, just kind of looking at these. Would this first one be a polynomial? I hear a no. How would it not be a polynomial?
Because the last one is the first and the second one. So
well, actually, we can combine those. Would be okay to do, and call that a what would it be, a plus 5x on the end? Then would you say it's polynomial?
Yeah.
Yes. So it's a polynomial in this stage. It's not a simplified polynomial, but it is a polynomial. All right. How about this guy? It's okay. I can have fractional coefficients. I can have, oh, wait a minute. Wait a minute. How could we write a square root with a exponent to the 1/2 power? That's a problem. Because this right here, any square root, I could write that as 2x to the 1/2 power. So actually, this is a problem. Because remember, I can't have fractional exponents. So actually, this is not a function. How about the f of x?
No.
No, because again, I could write that as 2x to the 1/2 power plus 7. So, nope, that's not. This guy?
No.
Nope, same reason, that -4 right there. How about this bad boy?
No.
Why do you say no there? I don't know. Just sounds good. Kind of on a roll.
Yeah. This is subtraction.
Okay, I'm going to write it like this. What if I wrote x plus 2 times 3x minus 1 to the -1 power?
Well, you can't do that.
Oh, yeah, you can. If you can express that in any way, just like up here, I didn't see a fractional exponent either. Well, the fact that you have a denominator here means something's downstairs, which means it's to a negative 1 power. Oh, yeah, so no, I thought you meant I can't write it a different way. So yes, no, yes, that is not a function. How about this guy? Okay, I hear yes, okay on that, because what is that 2 really? It's really just a 1/2 out in front of all that stuff. Would you agree with that? So yes, that would be just peachy. So what did I only have one yet? Yes and all, 2 yeses. All right. So the degree of a polynomial. You remember what the degree is?
Yeah.
Brad knows. What is it? The highest exponent. Very easy. And the sad part is, I will ask this question on the test, and I'll have an equation. I'll have it written out like this or something. And I'll ask you, what is the degree? And some of you will try to solve it. You'll go through stick it in your calculator. You'll try to find zeros. And all you have to do is go 5. So very simple, but remember, simple is okay. Be simple. So the degree of f of x, good. P, f, g, 2g, 2. All right, easy enough. Okay, do you remember how you classify triangles? Give me a name of a triangle. Okay, isosceles. Don't ask me to spell it. Isosceles, something like that. No, ISC. Isn't there a C in there? No, there's the C. I think there's an S in here. Yeah. Anyway, we know what we mean. What other kinds do you have? Okay, equilateral. What else do we have? Yep, got him.
Acute.
Acute. Obtuse. Woohoo! Big word. Scalene. One last one. Right triangle. Now, how did we classify these? These are classified by what? The sides, the length of the sides, right? By sides. What are these classified as? By angle. So I could have an isosceles acute triangle. I could have what else could I have? An equilateral acute, or combinations thereof. So when you're classifying polynomials, it's the same thing. We're going to classify them not by sides and angles, but we're going to classify them by degree and by number of terms. That's the 2 ways you classify polynomials. So, I'm just going to put this on here anyway. Let's write a little chart real quick. I'll try to squeeze it up here. We're going to put our polynomial in the first blank. And then we're going to classify by degree. And then we're going to classify by number of terms. So, if I give you x squared plus 2, by degree, what would that be? Okay, and what do we call a 2 degree? Quadratic. So it's a quadratic when you're talking about the degree. Number of terms, what would that be? How many terms do I have? And what do we call something with two terms? Binomial. Yeah. So this is a quadratic binomial. Makes sense. And you know all that? You just may have never put it together in your head. Let's say I have x minus 1. By degree, it's first degree. It's a line. It's linear. It's linear. So any equation that only has the highest exponent of 1, it's going to be a linear equation. How about by number of terms? Binomial again. So it's a linear binomial. Let's go with just plain old x cubed. By degree? Cubic. Very good. And by number of terms? Monomial. Mono meaning 1. Bi, of course, meaning 2. All right, how about x to the 4th plus 2x cubed plus 9? Okay, good. By the 4 up here, it's a quartic, like 4 quarts to a gallon. A quarter, that's 4 quarters to $1, that kind of thing. And this would be a trinomial. Very good. So this is a quartic trinomial. And then let's go with x to the 5th plus x to the 4th minus 2x cubed plus 2x squared minus 1. Simple. What do we call a 5th degree? Remember? Starts with another QU. What do you call it when a woman has 5 babies? There you go. So let's pick up on the quin idea. It's a quintic. Yep, quintic. Now we have 1, 2, 3, 4, 5 members of this, 5 terms. Do we have a name for cinco-eel? Thinking 5 cinco. Yeah, all we do is call this polynomial of 5 terms. They're all polynomials because poly means many. But once you get past 3, then you just start saying polynomial 4 terms, polynomial 5 terms, polynomial 100 terms. So only the first 3 have special names, mono, bi, and tri. So you know all that? Have you never put it together maybe in a chart like that? When we divide polynomials, we can divide polynomials, and we divide, when you do long division, we're going to use the factors, and this will all come back to you in just a second, but let me remind you. When you do long division, you use the factor. When you do synthetic division, you use the root. We'll talk about what that means. So let's use long division on this problem right here. So we're going to do x minus 2, which is a factor. And we're going to set up a long division house just like we did in Algebra 2, or actually, long division you started in 4th grade, something like that. Now, one thing you need to notice, though, what's missing in here? I went from x to the 5th to x to the 3rd. So when I'm writing this out, I need to put in plus 0x to the 4th minus x cubed. Whoops, missing something else there. I need to put 0x squared in there. Plus x minus 5. And then we start the fun. So this little guy right here will always be the boss of what you do. You always go back to him to ask him what to do. So the first thing I'm going to ask him is, how many times will this x go into x to the 5th? and that would be x to the fourth times, right? Because x to the fourth times x to the first will give me x to the fifth. But I also need to do x to the fourth times negative 2, which will give me negative 2x to the fourth. Which is why I needed to put a 0 in there above for my x to the fourth, so I'd be lining up like terms. Otherwise, I'd be trying to add a cube to a fourth, and that's not going to work. Then what do we do at that point? Remember? Sort of. We subtract, which changes the sign of both of those, causing that first one to cancel out, which is what we wanted to happen. And I add those two together to get 2x to the fourth. I'll bring down my x cubed. And I'll go back to Mr. Bossy and ask him, okay, Mr. X, how this time, how many times will you go into 2x to the fourth? I need 2 and an x and a cube. 2x cubed times x. 2x to the fourth. 2x cubed times negative 2. Negative 4x cubed. Subtract, which changes the sign of both of these. So now I have 3x cubed. I'll bring down the 0x squared. Go back to Mr. Bossy. X, how many times will you go into 3x cubed? We have 3, and then, yeah, 2 more x's. 3x squared. 3x squared times x. 3x squared times negative 2. And subtract, which will change the sign of both of those. I haven't brought down the x yet, have I? Man, this will be a long one. Then I'll go back to x. How many times will you go into 6x squared? And that will be 6x times. 6x times x. 6x squared. 6x times negative 2. Negative 12x. And I will subtract, change the sign of both of them. And I have a 13x. And then finally, I get to bring down my minus 5. So I ask the x minus the x. Mr. Bossy, you will go into 13x 13 times. 13 times x is 13x. And 13 times negative 2 is negative 26. Subtract, changes the sign of both, and it looks like I have a remainder of 21. So I have a remainder of 21, which, do you remember how you did this? You put 21 over whatever you were dividing by. That's times 2. So that whole thing is my answer. So I have a quartic, 1, 2, 3, 4, 5. Quartic polynomial of 5 terms with a remainder of 21 over x. Hopefully that rings a bell. Remember how to do that. And you'll remember how long and tedious that was. And then you'll remember synthetic division and think, why didn't we do them all that way? This is the same problem, but now let's remember how we did synthetic division. Remember that little slide that said long division, you use the factor, synthetic division, you use the root? What would be the root of x minus 2? If that was one of your factors, where would you graph that on the x-axis? You do it at positive 2, right? because you'd set that up equal to 0 and solve and get a positive 2. So I'm going to synthetically divide with a positive 2, not a negative 2. And then I'm going to write down the coefficients of each of these, but I've still got to remember I've got to put in zeros where I'm missing one. So I've got 1x to the 5th, no x to the 4th, negative 1x cubed, no x squared, 1x, and a negative 5. The first number you always bring straight down, no matter what it is, you bring it down. And then you go 2 times 1 is 2. You add those together. 2 times 2 is 4. Add those together. 2 times 3 is 6. Add those together. 2 times 6 is 12. Add those together. 2 times 13 is 26. Add those together. Then, remember this last little bar right here, this is your remainder right here. And then you walk up the line. So this is your constant, this is your x, this is your x squared, this is your x cubed, this is your x to the 4th. So my answer is going to be 1x to the 4th plus 2x cubed plus 3x squared plus 6x plus 13 with a remainder of 21. Now be careful here. Don't say 21 over 2. No, it's 21 over the x minus 2, what you were dividing by. And that took about 1/4 of the time, but if you'll compare that to the last answer, same answer, just a lot quicker. Okay, so that's synthetic division. Here's a hint. Only use synthetic division if the divisor is linear. In other words, if you're dividing by an x minus 1 or x plus 2, anything that's linear, you can divide by it with synthetic division. Because remember, you have to divide with a root. But if I have something other than that, if I'm dividing by x squared plus 1, I can't say the root is negative 1 because that is not an x. So if you had this, you'd have to use long division. You can only use synthetic over here when it's a linear that you're dividing by. All right. So let's go back to grade school. When you divided 25 divided by 3, you certainly don't need this in your notes. 3 goes into 25 8 times, and then you went 8 times 3 is 24. You added those. Nope, what am I saying? You add them, you subtract them. You subtract, and you got 1. And so you had a remainder of 1. So you started off in your life putting R of 1. And then as you got fancier, you said 8 with a remainder of 1/3. Then when you got really bright, you started putting in decimals, and your answer was 8.3, right? But here's the question. How did you check to see if this was right? When you very first started, you checked it by saying 8 times 3 is 24. And then what did you do to the remainder? You added it to it, right? And you had to make sure you got what you started off with. Well, the same thing holds true when you're doing synthetic division. Whatever your answer is this the same problem or is this a different problem? Okay. We're going to solve this one and we're going to check it. Luckily, it's a linear, so we get to use synthetic division, so it'll be nice and short and sweet. So I'm going to use a -1. I'm going to use the root. You need to put a 0 in for cubics, for squares. Or a good man, Charlie Brown. So I don't know when I turned that off, but we found that I made a mistake up here. So we changed all those, ended up with the correct answer if you are looking online. All right, factors. If the remainder is 0 when you're dividing, so if you get a remainder of 0 when one polynomial is divided by another polynomial, then the divisor and the quotient are factors of the dividend. That's a lot of math words. Basically, what it means is, let me ask you a question. Is 32 a factor of, is 5 a factor of 32? How do you know? Does it go in, doesn't go in evenly? If it goes in evenly, what's the remainder? 0. So by the same token, if I divide like I just did when I divided, since I got a remainder, that means that x plus 1 is not a factor of this guy. I can divide by him, but he's not a factor because it didn't come out even. That's what that theorem is saying. It's just with a lot of fancy words. So, yes, 24 divided by 6 is 4, so that makes, 6 a factor of 24. 36 divided by 5 is 7 with a remainder of 1. So that means 5 is not a factor of 36. Right?
The first one, our remainder is 0.
Uh-huh.
From 0 over 6. 0.
Yeah, you could think of it that way. Uh-huh. So let's do it with polynomials then. If this is your question, show that 3x squared plus 1 is a factor of 3x cubed minus 6x squared plus x minus 2. Show that it is a factor. Well, if it's a factor, then when I divide, what should happen? Should I get a remainder? Should not get a remainder. I should get a remainder of 0. So I'm just going to divide and see what my remainder is. Can I use synthetic division? Wish I could. All right. I use this one on purpose because with long division, you've got to do the same thing. I've got to put in a 0x. That's a funny little 0. I've got to put in a 0x and a plus 1 into, I've got a cubic, I've got a squared, I've got an x, and I've got a constant. So I'm going to ask myself, now I've got a big man who's the bossy guy. 3x squared, how many times do you go into 3x cubed? What do I need? An x. So x times 3x squared is 3x cubed. X plus 0x is 0x squared. X times 1 is x. And I'm going to subtract, which is going to change the sign and everything. So now I have a negative 6x squared plus no x's. Bring down my minus 2. Go back to bossy pants, 3x squared. How many times do you go into negative 6x squared? And you will tell me how many times? Negative 2 times. So negative 2 times 3x squared, negative 6x squared. Negative 2 times 0x is 0x's. Negative 2 times 1 is negative 2. And lo and behold, when I change the signs of everything, everything will cancel out, and I have a big fat 0 for an answer, for a remainder. So I just showed or proved that 3x squared plus 1 is a factor of that. Very logical thing to do. You have all the skills now to do it. The remainder theorem basically says that if you have a polynomial and you divide it by a linear, then whatever the remainder is the f of this. Okay, that sounds very, very confusing, Ms. McGinnis. I totally get it. So, let me show you what that means. In other words, if I have x squared minus x minus 6 divided by x plus 2, let's see what we get here. I'm going to take, and I can do this synthetically. So real quick here, I'm going to divide. And I get x minus 3. So, the remainder here is 0, and this thing that I put in right here, they are an ordered pair that actually are on this parabola. Therefore, if this is an ordered pair on the parabola, that's certainly not going to hack it. I better draw my parabola first. So -2, 0. Let's say this is a -2 right here. So if -2, 0 is one of my roots, then if I said what is the p of -2, I could plug -2 in here and get 4 plus 2 is 6, minus 6 is 0. Well, that makes sense because -2, 0 is a point, and this makes a point as well, and this makes the same point. It makes sense how that all fits together? So if you divide and you get a 0, turn that into an ordered pair, and when you do, then you go, oh, that's an x-intercept. Bingo. And that also means that the p of -2, if you stuck -2 into this equation for x, you'd end up with 0. So, let's have, if you have this equation right here, this polynomial of 4 terms, quartic, and I want you to find the p of 2 in 2 ways. So the first way I'm going to do it, you meant to write that down. The first way is I'm just going to plug in a 2 into the original equation. So that's going to give me 3 times 2, 4, 8 times 2 plus 11 times 2 plus 1. And somebody be ready with your calculator. Give that to me. Uh, 38. Looky there. It worked. That tells me that 239 is a point on the graph, and the p of 2 is 39, which makes sense because that's the x, that's the y, that, and all one big puzzle, and it works. Okay? Let me see. Are we near done? Do we need to? Yeah, we might need. Okay, let's take a little break real quick because we've got quite a bit more. Okay, here's some connections. Okay. If the f of x is a polynomial, then if one of the following statements is true, they're all true. So in other words, let me say it again, if f of x is a polynomial, then if one of the following statements is true, they are all true. If R is a zero of f, then R is also an x-intercept of f. Did you believe that? Did you buy that? You understand that? Because zeros and x-intercepts are the very same thing. And if you know that R is a zero of f, R is an intercept of f, then x equals R is one of the solutions, right? Because solutions and x-intercepts and zeros are all the same thing. And if, let's say R is 6, just for while we're talking about this. So if I say 6 is a 0, then I know that 6 is also an x-intercept. I know that 6 is a solution. And here's the last thing that you need to pick up. Then that also means that x minus 6 is a factor, right? This is a root, then its factor is x minus 6. Every one of those would be true. 6 is a 0, 6 is an x-intercept, 6 is a solution, x minus 6 is a factor. Okay, big picture, that should all make sense to you. All right, so in other words, these are all names for basically the same thing. Roots, x-intercept, zero solutions, and they can all be found from the factor x minus whatever your number is. Okay, so we have this polynomial. This is a quadratic trinomial. What are its factors? What do we got? 4 and 10? And negative, positive. So there's the factors. So if those are the factors, then what are the solutions? What x's would make this statement true if I were to put a 0 there? Okay, x equal negative 4, x equal 10. That's my solutions. What are my x-intercepts? Now, x-intercepts you write as an x-intercept. So they're going to be ordered pairs. Turn it around though. It's x-intercept. There you go. Yep. Negative 4, 0, and 10, 0. I knew it. I read your mind. Zeros are going to be negative 4 and 10. Be careful that you don't write, some of you picked up on your test, I'm pretty picky about form. If I ask you for the zeros and you put this comma here and put this in parentheses, why would I have to count that wrong? That looks like an ordered pair. And negative 410 is not a 0. So watch your form. Think about, what am I writing down? Am I writing down a point? Or am I just writing down two things? What am I writing down? And my roots would be, again, negative 4. They're not. It's just a different term for the very same thing. Yep. Yep. And they're called zeros because you get them by setting your y equal to 0. Or because they're x-intercepts where the y is always 0. And as you get higher and higher in your math classes, they start calling them roots almost constantly. They quit calling them anything else and start calling them roots. And actually, okay, here is the most basic of all definitions that I guarantee you some of you will miss on your tests. A polynomial of a degree of n has at most n zeros. A polynomial of a certain degree, I of n, has at most n distinct zeros. You know what? This should not be in there because I'm just thinking of, let's take a quadratic. Let's take a quadratic like this. That is going to be two imaginary solutions, right?
But wouldn't you be able to take out at most if you took out real?
Oh, maybe that's what the definition's getting at most. So some of them could be imaginary. You're right. Yeah, that's what they're getting at. So I don't need to take, I mean, do you see what I'm debating in here? It doesn't mean like if you have an X to the fourth that you're going to have 4 real solutions, because some of them may be imaginary. But that's why this says at most. I'm second guessing the book's definition. I shouldn't do that. Shouldn't do that at all. Yeah. I know. It's hard, pretty hard reading math books. But it's not impossible.